Some cities disappear slowly, conquered by armies or devoured by time. Others are erased in seconds. Temperatures exceeding 2,000 degrees Celsius that melt bricks until they become glass. Bodies vaporized instantly, heat so extreme that it creates microscopic diamonds in the ground. This shouldn't be possible with ancient technology. However, the evidence is there. Mohenjo-Daro, Tal el Hammam, Herculaneum, Port Royal. Prosperous and advanced cities reduced to ashes in a matter of minutes. The strangest thing is that these catastrophes, separated by thousands of years and kilometers, show identical patterns of destruction. Modern science is beginning to decipher these mysteries, revealing a disturbing pattern that challenges everything we thought we knew about the past. Chapter 1. The exact moment when everything burned. Any morning in Mohenjo-Daro, year 1900 before Christ, the streets bustled with the normal activity of one of the most sophisticated cities in the ancient world. Merchants hawked their wares. Children ran between the fired brick houses. Women transported water through the most advanced drainage system the world had ever seen. Everything was routine. Then, in a matter of seconds, everything changed. When Sir John Marshall's archaeologists began systematic excavations in 1922, they encountered something they didn't expect. It wasn't gold. It wasn't treasures. It wasn't glorious inscriptions. It was bodies. 14 skeletons scattered throughout the western area of the city, near what they now call the DKG zone. But these weren't ceremonial burials. They were sprawled in the streets, some face down, others twisted as if they had been surprised in the middle of something. The most disturbing find was a complete family, a man, a woman, and 3 children, embracing in a room. The position of their bones suggested they had tried to protect themselves from something. But from what? There were no signs of weapons, no evidence of battle, no walls destroyed by siege. The question that tormented archaeologists from the first day was simple. What can kill an entire family in seconds, leave them exactly where they fell, and make a prosperous city be completely abandoned? The answer came when they began to analyze the construction materials. The bricks of Mohenjo-Daro weren't just fired, some were literally melted, turned into glass. And we're not talking about a few bricks here and there. We're talking about entire areas where ceramics had melted and solidified as if they had passed through an industrial furnace. For a brick to turn into glass, you need temperatures exceeding 1,500 degrees Celsius. To put this in perspective, a typical house fire reaches about 600 degrees. A modern ceramic kiln reaches 1,200 degrees Celsius. We're talking about temperatures that exceed what most current industrial furnaces can generate. But here comes the strange part. These vitrified zones aren't throughout the entire city. They're small, localized patches, as if the heat had been selective, as if something had specifically targeted certain areas and melted them with precision impossible for technology from 4,000 years ago. Scientists tried to explain it. Some spoke of exceptionally powerful lightning. Others suggested intense fires fueled by highly flammable materials, but none of these theories explain the selective distribution of damage or the extreme temperatures recorded in laboratory analyses. David Davenport, in 1979, proposed something much more controversial. He suggested that Mohenjo-Daro had been destroyed by some type of massive energy explosion, something that generated heat and pressure beyond any known natural phenomenon. His theories were rejected by the conventional scientific community, but the questions he raised remain without satisfactory answers. The 14 skeletons found in Mohenjo-Daro tell a story that doesn't fit any known pattern of destruction. For a city that probably housed tens of thousands of people, finding only 14 bodies is statistically impossible if we're talking about an invasion, an epidemic, or even a typical natural disaster. These bodies show no signs of weapon trauma. There are no sword cuts, no embedded arrowheads, no signs of hand-to-hand combat. There's also no evidence of disease or malnutrition that would suggest slow death from epidemic or famine. What they do show is something much more disturbing, positions that suggest instant death. Some are with their hands raised, as if protecting themselves from something coming from above. Others seemed to have fallen mid-step, as if they had been frozen in time. The family of 5 found embracing presence an even more disturbing scenario. The position of the bones suggests they had enough time to recognize the danger, seek shelter, and embrace, but not enough to escape. What type of threat gives people a few seconds to react but not to flee? Later analyses revealed something stranger. Some of the bones showed signs of exposure to extreme heat, but not uniformly. It was as if the heat had arrived in waves or pulses, affecting some parts of the body more than others. After whatever happened in Mohenjo-Daro, the city was completely abandoned. Not gradually, not after a slow decline. From one day to the next, one of the most advanced civilizations in the ancient world simply vanished. And here comes the truly strange part. The city remained abandoned for 300 years. 300 years in which no one dared to reoccupy one of the most strategic and fertile locations in the region. For a civilization that had built drainage systems that wouldn't be seen again until Imperial Rome, that had developed standardized weights and measures, that traded from Mesopotamia to the Indian subcontinent. Simply disappearing makes no sense. There's no evidence of prolonged war. The drainage systems remained intact. The streets maintained their perfect urban planning. The multi-story houses remained structurally sound. It was as if the inhabitants had gone out for lunch and never returned. The Indus Valley civilization, which had flourished for more than 1,000 years, entered terminal decline after this event. Sister cities like Harappa also began to show signs of gradual abandonment. It's as if what happened in Mohenjo-Daro had been a warning that no one wanted to ignore. When modern scientists analyze the abandonment patterns, they find something they can't fully explain. It wasn't erosion, it wasn't gradual climate change, it wasn't resource depletion. It was something sudden, something frightening enough to make an entire civilization decide it was better to seek new territories than to stay and rebuild. But Mohenjo-Daro wasn't the only city that experienced this type of instant destruction. Thousands of kilometers away and centuries in the future, another city would witness even more extreme temperatures, where heat would not only melt bricks, but convert organic materials into something that would defy the laws of preservation. And that story is documented to the minute, with the precision of a clock that stopped forever. Chapter 2. 3,600 Years of Silent Ashes. In the Jordan Valley, barely 11.7 kilometers from the river that gives it its name, stands a mound that archaeologists call Tal el-Hammam. At first glance, it doesn't seem like much, just packed earth, scattered rocks, and the typical silence of archaeological sites. But when Stephen Collins and his team from Trinity Southwest University began excavating in 2005, they encountered something that would forever change our understanding of what fire can do to a civilization. Tal el-Hammam had been, during the Middle Bronze Age, the largest urban center in the entire southern Levant. We're talking about 36 hectares of extension, with an upper tell that rose 30 meters above the surrounding plain. For more than 1,000 years, from the late Chalcolithic period to the Iron Age, this city had been the beating heart of the region. It had massive fortifications, a palatial complex of 4 to 5 stories, and a 4-meter-thick mud brick wall that protected it. And then, around 1650 before Christ, all of that disappeared in an instant. The evidence is in a destruction layer that cuts through the entire city like a scar. A layer between 1.5 and 2 meters thick, composed of ashes, charcoal, pulverized bricks, and debris deposited chaotically. But it's not the type of destruction you'd expect from a war or earthquake. It's something much more violent, much more extreme. When researchers took pottery and brick samples to the laboratory, the results were devastating. Temperatures had exceeded 2,000 degrees Celsius. To give you an idea of what this means, copper's melting point is 1,085 degrees. Iron melts at 1,538 degrees. We're talking about temperatures that exceed what's needed to melt most metals. The pottery fragments found at the site weren't just broken, they had completely vitrified outer surfaces, turned into glass. The mud bricks were melted. The ceiling plaster had melted and solidified into strange shapes. They even found evidence that some textile materials like carpets and tapestries had burned so quickly that they left perfect holes in the ash layer. But here comes the truly disturbing part. They also found microscopic diamonds, specifically a type called lonsdaleite. which forms only under conditions of extreme pressure and temperature, typically associated with meteorite impacts. Along with these micro-diamonds, shocked quartz grains appeared, a mineral that only forms when rock is subjected to pressures between 5 and 10 gigapascals. The human remains told an even more sinister story. The few skeletons found in the destruction layer were completely disarticulated. We're not talking about bones broken by building collapse. We're talking about extreme fragmentation, as if the bodies had been literally shattered by an explosive force. The researchers reported a 100% mortality rate in the affected area. But perhaps the most chilling detail was the directionality of the debris. Everything from pottery fragments to charred bones had been dispersed in a consistent pattern from southwest to northeast. The remains of burned grains, charcoal, and bone fragments appeared scattered at distances of several meters, as if they had been thrown by impossible speed winds. And then there was the salt. The destruction layer contained salt concentrations of 4% by weight, when normal levels in the region are less than 1%. This hypersalinity had turned the soil into something practically sterile. Tall El Hammam was not reoccupied immediately after the destruction. In fact, it remained abandoned for centuries. The devastation wasn't limited to the city itself. Archaeologists found evidence that at least 120 settlements within a 25-kilometer radius had been simultaneously abandoned. The region's population, estimated at tens of thousands of inhabitants, plummeted to only a few hundred scattered nomads. This massive abandonment lasted between 300 and 600 years. The researchers, led by members of the Comet Research Group, proposed an explanation that sounds like science fiction, a cosmic airburst of super Tunguska magnitude. Basically, an object from space that exploded in the atmosphere with a force several thousand times greater than the Hiroshima bomb. Their computer simulations suggested that such an event could generate exactly the type of evidence found at Tall El Hammam: the extreme temperatures, the pressure that created the microscopic diamonds, the directional dispersion of debris, and the hypersalinization of the soil. However, this hypothesis faced fierce academic scrutiny. In April 2025, the main paper describing these findings was formally retracted by the journal Scientific Reports, adding a layer of controversy to the discoveries. Critics argued that the site's association with specific biblical narratives had compromised the scientific objectivity of the study. But regardless of controversies about its interpretation, the physical facts remain. Something turned a prosperous Bronze Age city into a layer of ashes and molten glass in a matter of minutes, leaving behind evidence of temperatures and pressures that defy any conventional explanation. Chapter 3. The Furnace that Preserved History. On August 24, 79 AD, the inhabitants of Herculaneum thought they had dodged a bullet. From their windows, they could see the ash column from Vesuvius rising toward the sky, but the winds carried it eastward toward Pompeii. Their city, situated on the western slopes of the volcano, seemed to be safe. Some residents even went out onto their villa terraces to observe the spectacle. It was the last mistake they would make. At dawn on August 25th, the volcanic column collapsed. What had been a controlled rain of ash became something completely different. Pyroclastic flows that descended the volcano's slopes at speeds of up to 100 kilometers per hour. These weren't simply hot gases. They were rivers of death composed of superheated gas, fine ash, and rock fragments that moved like liquid avalanches. The temperatures of these flows ranged between 400 and 500 degrees Celsius. To put this in perspective, water boils at 100 degrees. At 400 degrees, human flesh vaporizes instantly. Brains boil inside skulls and make them explode, and that's exactly what happened to the inhabitants of Herculaneum who didn't manage to escape. The first pyroclastic flow was the most lethal. It arrived so fast that most people didn't have time to even leave their houses. They were simply consumed by a heat wave that turned everything organic into vapor in fractions of a second. But the subsequent flows were what created the most extraordinary archaeological miracle in the ancient world. Unlike Pompeii, which was buried by light and porous ash, Herculaneum was buried by a dense and humid mass that acted as a perfect sealer. This mixture of ash, rock fragments, and superheated gases behaved like boiling mud, penetrating every crack, every space, every corner of the city. When it cooled and solidified, it created a completely anaerobic environment that preserved organic materials in a way that had never been seen before. The result was that Herculaneum became a carbonized time capsule. Wood elements, instead of decomposing, carbonized, transforming into a coal-like substance that maintained its original shape for almost 2,000 years. In the House of the Bicentenary, archaeologists found a perfectly preserved wooden bed. In the House of the Gem, they discovered a wooden lattice screen that remained in its original place. But the real treasure was in the Villa of the Papyri. This magnificent seaside residence, which had belonged to Lucius Calpurnius Piso Caesoninus, Julius Caesar's father-in-law, contained the only intact papyrus library in the Roman world. When the villa was discovered in the 18th century, workers initially mistook the carbonized scrolls for wooden logs. The efforts of Antonio Piaggio, a Neapolitan scholar and the patronage of the Bourbon monarchy, were necessary to develop methods for unrolling and reading these fragile documents. On June 19, 1753, the first attempt was made to unroll a Herculaneum papyrus. The process was agonizingly slow and delicate, often resulting in damage, but it marked the beginning of the decipherment of these ancient texts. The scrolls from the Villa of the Papyri, which number almost 1,800, offer a unique view of ancient Greek philosophy, particularly Epicureanism, since many of the texts are works by the Epicurean philosopher Philodemus. The volume of these scrolls is incomparable at any other archaeological site. In the 21st century, scientists have been able to apply advanced imaging techniques such as X-ray phase contrast tomography to virtually unroll and read the scrolls without physically damaging them. This technology, which began showing promising results in the early 2000s, allows researchers to detect ink on the carbonized papyrus, which was previously invisible to the naked eye and traditional X-rays. The preservation of organic material extended far beyond wood and papyrus. Food items like bread loaves, figs, and dates turned to charcoal have been found. The carbonized remains of textiles, fishing nets, and even ropes offer glimpses of the industries and daily life of Herculaneum's inhabitants. On May 19, 1982, when archaeologists explored the boat sheds on the ancient shore, they discovered the first human remains in Herculaneum. For years, it had been believed that most inhabitants had evacuated successfully. This belief was based mainly on the initial scarcity of human remains found within the city itself. However, the discovery of the boat sheds dramatically changed this understanding. In these shelters, hundreds of skeletons were found huddled together, crouched as if seeking shelter. These individuals, probably waiting for rescue or trying to escape by sea, met their end in the first, most intense pyroclastic flow. When these skeletons were first examined, scientists observed a reddish-brown residue on some of the bones that, after analysis, was determined to be vitrified brain matter. This extremely rare phenomenon, resulting from brain tissue being instantly heated to temperatures so high that it turned to glass, provided irrefutable evidence of the extreme thermal shock experienced by the victims. The preservation of multi-story buildings, unlike many in Pompeii that collapsed under the weight of ash, allows for a more complete understanding of Roman urban planning and housing. The House of the Relief of Telephus, for example, preserves its second floor, offering a rare view of upper-level Roman residences. The elaborate frescoes and mosaics, often in better condition than those of Pompeii due to the protective layer of volcanic material, show the artistic tastes of Herculaneum's wealthy inhabitants. The House of Neptune and Amphitrite features an exquisitely preserved mosaic of the sea god and his consort, with vibrant colors that remain striking after almost 2 millennia. The study of Herculaneum continues to provide new insights. Modern excavation techniques are much more refined than those of the 18th and 19th centuries, allowing for meticulous documentation and preservation. Scientists now employ advanced tools such as ground-penetrating radar to map buried structures before excavation, minimizing damage. The supreme irony of Herculaneum is that it was the extreme violence of its destruction that created the perfect conditions for its preservation. The same heat that killed its inhabitants instantly carbonized their possessions, creating an archive of first-century Roman life that is incomparable anywhere else in the world. Chapter 4. When Lisbon burned for a week. The morning of November 1st, 1755, dawned in Lisbon with deceptive tranquility. It was All Saints' Day, one of the most sacred dates in the Catholic calendar, and the city's churches overflowed with faithful. Thousands of candles flickered on altars in chapels and homes, creating an atmosphere of devotion that extended throughout the capital of the Portuguese Empire. At 9:40 in the morning, that serenity disintegrated. The ground began to move with a violence that defied all description. It wasn't a gentle tremor that gradually increases. It was a brutal shake that lasted between 6 and 7 minutes, an eternity for those who lived through it. Witnesses described how the earth undulated like ocean waves, opening in cracks that swallowed people and entire objects. The magnitude of the earthquake is estimated between 8.5 and 9.0 on the moment magnitude scale, with its epicenter on a fault in the Atlantic Ocean southwest of Portugal. The seismic waves were felt as far away as Finland and North Africa, giving us an idea of the monstrous energy that had been released. The church bells, some of which weighed several tons, began to ring wildly on their own. The royal palace, a magnificent structure on the shore of the Tagus, collapsed as if it were made of cards. The great royal opera, which had barely been completed the previous year, became a pile of rubble. The churches, packed with devotees, transformed into death traps when their heavy stone ceilings and ornate facades collapsed, burying thousands under tons of masonry. But if the earthquake was devastating, what came after was what really turned Lisbon into hell. Thousands of votive candles that had been lit for the religious celebration were overturned by the violence of the tremor. Kitchen fires in houses, oil lamps in residences, and the debris of wooden buildings provided abundant fuel for what would become one of the most destructive urban fires in history. The narrow, winding streets of medieval Lisbon, now blocked by debris, made any attempt to fight the fire impossible. To make matters worse, a strong wind, possibly caused by the atmospheric disturbances of the earthquake, fanned the flames until isolated fires became a generalized conflagration. The fires burned for days. Some accounts claim they lasted almost a full week, consuming what the earthquake had spared. The Royal Library, which contained more than 70,000 volumes, was reduced to ashes. Centuries of accumulated knowledge, maritime exploration maps, unique historical documents, all turned to smoke and ash. The Palace of the Inquisition, with its sinister history, was also devoured by the flames, and with it all its records were lost. In a sense, the fire did what centuries of critics had failed to achieve: physically erase the archives of one of Europe's most feared institutions. The earthquake survivors were forced to flee from the ruins, pushed toward the riverfront by the relentless heat and smoke. Many believed that the open space of the Tagus estuary would offer safety. It was a fatal mistake. Approximately 40 minutes after the initial earthquake, something occurred that survivors couldn't explain. The waters of the Tagus withdrew dramatically, exposing the muddy riverbed scattered with lost cargo, shipwrecks, and harbor debris. This extraordinary spectacle attracted many curious survivors to the exposed riverbed, some to scavenge among the remains, others simply to witness the strange phenomenon. It was the calm before the storm. Moments later, the first of 3 massive waves generated by the same underwater seismic event rushed toward the estuary. The largest of these waves, estimated at up to 6 meters high in Lisbon, crashed against the city, sweeping away those on the exposed shores, destroying docks and carrying ships inland. The tsunami wasn't limited to Lisbon. Its destructive power was felt along the coasts of Portugal, Spain, and North Africa. In Morocco, coastal cities like Safi and Agadir were flooded with significant loss of life. Its effects were even observed across the Atlantic in the Caribbean, where harbor waters rose and fell unusually. The combined assault of earthquake, fire, and wave left Lisbon in ruins, a landscape of charred rubble and drowned bodies. Death estimates for Lisbon alone varied widely, from 10,000 to 100,000, with tens of thousands more in the affected regions. In the midst of this devastation emerged a figure of extraordinary resolve: the Marquis of Pombal, Sebastião José de Carvalho y Melo. His famous command, chillingly direct, "Bury the dead and feed the living," encapsulated his immediate priorities. He quickly imposed martial law, organized relief efforts, dispatched troops to prevent looting, and organized the collection of bodies to prevent epidemics. But Pombal did more than simply manage the crisis. On December 26, 1755, barely weeks after the disaster, he sent a detailed questionnaire to every parish in the kingdom. This was an unprecedented act of scientific data collection. The questionnaire meticulously sought information about the earthquake's effects, the exact time it began, its duration, the number of aftershocks, the type of damage suffered by buildings, the behavior of animals before and during the tremor, the changes observed in wells and springs, and crucially, the tsunami's impact. The responses, though varied in their scientific rigor, provided a treasure trove of empirical data that allowed early natural philosophers to begin assembling a more coherent understanding of seismic events. This work laid the foundation for the birth of modern seismology. The Lisbon earthquake also sent profound shockwaves through Europe's intellectual landscape. Voltaire, the celebrated French philosopher, was particularly outraged by the disaster. In 1756, he wrote his poem on the Lisbon disaster, a direct and biting indictment of Leibnizian optimism. He questioned how a just and good God could allow such catastrophe, arguing that the idea that all is well was a cruel mockery in the face of such widespread agony. His later and perhaps most famous work, the satirical novel Candide or Optimism from 1759, continued to satirize this philosophy through the character of Dr. Pangloss, an unshakable optimist who, despite enduring countless misfortunes, including a fictional version of the Lisbon earthquake, continues to insist that everything is for the best in the best of all possible worlds. The event served as a catalyst, pushing philosophical thought toward more empirical observations and fewer purely metaphysical explanations for natural phenomena, fostering a nascent skepticism toward grand, all-encompassing theories of divine order. Chapter 5. The Sinful City That Sank in Flames. In the second half of the 17th century, Port Royal in Jamaica had gained a reputation that resonated throughout the Atlantic: the wickedest city on earth. It was not an exaggeration. This city defied all conventional morality, a bustling hive where fortunes were made and lost with dizzying speed, and where the line between legitimate commerce and absolute piracy often blurred to the point of disappearing. Its streets swarmed with corsairs, merchants, enslaved individuals, artisans, and a transient population drawn by the promise of immense wealth. Gold, silver, and exotic goods plundered from Spanish galleons flowed through its docks, fueling an economy of unprecedented extravagance. The city boasted an astonishing number of taverns, brothels, and gambling houses that far exceeded any other settlement of its size in the English colonies. The stately houses, built of brick and stone, rose several stories, testament to the rapid accumulation of wealth by their inhabitants. Ships from all over the world, loaded with goods and stories, perpetually crowded its deep natural harbor, making it the most important English port in the New World. It was a place of vibrant and chaotic life, a testament to human ambition and greed, a city living on the edge both literally and figuratively. The very foundation of Port Royal was precarious, built largely on a tongue of sand and coral that extended into the sea, an unstable base for such a dense and heavily constructed urban center. This geological vulnerability, combined with the city's infamous moral decadence, led many of its more pious contemporaries to see its eventual fate as divine retribution. And indeed, on a seemingly ordinary Wednesday, June 7, 1692, at approximately 11:43 in the morning, the city's extraordinary existence came to an abrupt and cataclysmic end. The air, which moments before had been filled with the clamor of merchants, the shouts of sailors, and the laughter from taverns, suddenly tore with a terrifying roar. The ground beneath the feet of its 6,500 inhabitants began to rock and convulse with unimaginable violence. The earthquake, estimated between magnitude 7.5 and 7.8, struck with devastating force. It was not a single prolonged tremor, but a series of 3 distinct shocks, each more destructive than the last, occurring within the span of mere minutes. The first shock was severe, causing buildings to sway and cracks to appear. The second, however, was the truly annihilating blow. The sandy, water-saturated substrate upon which much of Port Royal had been built experienced a phenomenon known as liquefaction. The solid ground, saturated with groundwater, momentarily lost its strength and behaved like a liquid. Buildings, some weighing hundreds of tons, were swallowed whole, sinking into the churned earth as if it were quicksand. Streets buckled and opened up, creating fissures that swallowed people and structures alike. The very landmass of the city began to slide and crumble into the sea. Reverend Emmanuel Heath, the city's rector, miraculously survived and later recounted how the earth would open and close, swallowing people before his very eyes. He described seeing the bell tower of his church, St. Paul's, collapse, and then the church itself being consumed by the earth. But the earthquakes were not the only source of destruction. The violent collapse of buildings, the overturning of braziers and oil lamps, and the rupture of storage facilities created multiple fire outbreaks across the ruined city. The wooden structures, though soaked by seawater that rushed in, still contained oils and flammable materials that quickly ignited. The marine winds that followed the seismic collapse fanned these flames, creating a hellish scenario where fire and water competed to consume what remained of the city. Survivors who had escaped the initial sinking now had to flee from fires that spread across the floating debris. In less than 10 minutes, 2/3 of Port Royal, including its most densely populated and wealthy districts, had disappeared beneath the waves, taking with them an estimated 2,000 of its inhabitants. Thousands more were injured and many succumbed to disease in the days and weeks that followed, as the remaining parts of the city were overwhelmed by chaos, lack of sanitation, and the stench of death. For centuries, Port Royal lay largely undisturbed beneath the waters of Kingston Harbour, a forgotten relic of a bygone era. Its stories were preserved by the very catastrophe that destroyed it. Although some early salvage efforts were made by survivors and opportunistic divers in the immediate aftermath, recovering easily accessible valuables, most of the sunken city remained intact. This unique, oxygen-depleted environment proved to be an extraordinary preservative, preventing the decomposition of organic materials that would normally disintegrate in salt water. It was not until the mid-20th century that serious archaeological interest in the sunken city began to emerge. In the 1950s, pioneering underwater archaeologist Edwin Link initiated some of the first systematic explorations. His work, though limited in scope by the technology of the time, confirmed the incredible state of preservation and hinted at the treasures of information that lay buried. However, it was the tireless dedication of Robert Marks, beginning in the 1960s, that truly brought Port Royal back to the spotlight of underwater archaeology. Marks, an American adventurer and historian, spent years meticulously mapping and excavating portions of the sunken city. It was during one of Marks's expeditions, specifically in 1967, that one of the most iconic discoveries was made: a remarkably preserved pocket watch, its hands frozen precisely at 11:43. This artifact provided chilling confirmation of the exact moment the earthquake struck, a poignant and tangible link to the disaster. Marks's extensive excavations uncovered not only isolated artifacts but entire sections of remarkably intact buildings. He discovered a building believed to be a liquor house, complete with pewter tanks, bottles, and even the remains of their contents. In other areas, he found a kitchen with pots and pans still on the hearth, and a dining room with plates and utensils scattered as if the occupants had just gotten up from a meal. Groundbreaking later work was conducted by a team from Texas A&M University, led by Dr. James Parent, beginning in the late 1980s. This multi-year project employed more advanced archaeological techniques, including precise mapping, systematic excavation grids, and careful documentation. In 1990, during the Texas A&M project, archaeologists discovered a well-preserved section of a building that included a large quantity of ceramics, including Chinese porcelain and locally made pottery. Scientists analyzing these ceramic fragments were able to trace trade routes and consumption patterns, revealing the global scope of Port Royal's trade and the diverse origins of goods available to its inhabitants. Perhaps even more compelling were the organic materials recovered from the anoxic layers. Archaeologists found wooden furniture, leather shoes, textiles, and even food remains, all remarkably preserved. In a specific dive in 1989, a leather shoe was found, its stitching still visible, offering a tangible connection to an individual who walked the streets of Port Royal more than 3 centuries ago. Chapter 6: The Mountain That Devoured a Civilization. In the year 1600 before Christ, the island we now know as Santorini was a completely different place. It was then called Thera, and on its southern coast stood one of the most prosperous cities of the Bronze Age world, Akrotiri. It was a vibrant metropolis that rivaled any urban center of the time, a commercial hub that connected Crete, Cyprus, Syria, and even Egypt in an exchange network that defined Aegean civilization. Akrotiri was not just prosperous, it was sophisticated. Its streets were meticulously planned, some even paved. Its drainage system was so advanced that it included clay pipes for efficient wastewater management and even evidence of interior sanitary facilities within certain buildings. The multi-story buildings, some 2 or 3 stories high, were constructed with stone and wood, demonstrating advanced understanding of structural engineering. But what truly distinguished Akrotiri was its art. The walls of private houses and public spaces were adorned with vibrant frescoes that captured scenes of daily life with a vividness that made you feel as if you could walk straight into those painted worlds. Unlike many ancient wall paintings that have faded over time, Akrotiri's frescoes retain their vivid colors and intricate details thanks to the unique preservation conditions that awaited them. The fisherman fresco showed a young man holding a string of fish, emphasizing the importance of fishing to the city's economy. The boxing children fresco depicted 2 young men facing each other in a boxing match, dressed in protective gear, suggesting the existence of athletic training possibly linked to religious or ceremonial activities. The saffron gatherer's fresco, which represented women and monkeys collecting saffron, a valuable spice and dye, probably symbolized a ritual offering to a goddess, underlining the cultural and religious significance of saffron. The ladies' fresco in the House of the Ladies portrayed women in elaborate Minoan-style dresses and makeup, suggesting high status and participation in religious festivals. But perhaps the most impressive was the flotilla fresco, a 6-meter-long artwork from the West House that depicted a maritime procession with ships sailing between 2 ports, probably illustrating a religious festival or ceremonial journey. This piece powerfully emphasized Akrotiri's extensive maritime connections and its cultural importance as a trading center. Akrotiri's trade networks were truly extensive. Its strategic location allowed it to serve as a vital maritime hub that connected the Minoans with distant lands across the Aegean and the broader Mediterranean. Archaeological findings reveal imported luxury goods such as ivory, precious stones, and Kamare-style pottery from Crete, as well as connections with mainland Greece, the Dodecanese, Cyprus, Syria, and Egypt. The presence of molds and crucibles suggests that Akrotiri was an important center for copper processing, a crucial commodity in the Bronze Age. This robust trade network contributed significantly to the city's affluence and facilitated the spread of cultural ideas and artistic styles, particularly Minoan ones, which strongly influenced Akrotirian culture. But all the wealth, all the art, all the sophistication were about to disappear in the most violent way imaginable. The events leading to the eruption are becoming clearer through archaeological evidence. Before the main eruption, the island of Santorini experienced severe preliminary seismic tremors, strong earthquakes that caused significant damage to the city. Evidence has been found of collapsed buildings and attempts to rebuild them, indicating that the inhabitants were aware of the impending disaster. The accumulated debris and volcanic ash from these initial events even reached the second floor in some places, leading to some first floors being converted into basements and new entrances being added directly to the upper levels. It is believed that these warning signs, along with minor precursor tephra falls that would have given the population several months' notice, allowed Akrotiri's residents to evacuate the city. This explains the striking absence of human remains at the site, a marked contrast to Pompeii, where inhabitants were caught by surprise. It is assumed that people fled as quickly as possible, leaving behind their belongings, which were then perfectly preserved by subsequent layers of volcanic ash and pumice. The eruption itself involved multiple phases. A thin initial ash layer that shows no significant erosion indicates that the population had time to escape before the more intense volcanic activity. The first major phase, known as BO1/Minoan A, deposited up to 7 meters of pumice and ash. Subsequent phases, BO2/Minoan B and BO3/Minoan C, involved pyroclastic surges and lava fountains that completely destroyed any structures not already buried and probably initiated the caldera collapse. The final major phase, BO4/Minoan D, was characterized by diverse activity including base surge deposits, lava flows, and lahars, and completed the caldera collapse, generating massive tsunamis that would have impacted coastal areas across the Aegean, including Crete. The eruption expelled an estimated 15 billion tons of magma into the air, reaching heights of 32 kilometers. The thick layers of volcanic material, in some places reaching 40 meters, buried Akrotiri, effectively creating a time capsule. The systematic excavation of Akrotiri began in 1967, led by Greek archaeologist Professor Spiridon Marinatos. Marinatos had a theory dating back to the 1930s that the Thera volcano eruption might have caused the collapse of Minoan civilization on Crete, and he initiated excavations to investigate this hypothesis. He began by opening a series of test trenches across the bed of a ravine, guided by local farmers who had reported finding pottery and walls after heavy rains. Almost immediately, Marinatos realized he had stumbled upon something extraordinary. Prehistoric buildings that still stood 2 or 3 stories high, with almost every building showing evidence of rooms decorated with wall paintings. This impressive discovery led him to abandon his original theory, dedicating his time and resources to the systematic excavation of this remarkable city. One of the immediate challenges faced by Marinatos and his team was the preservation of the exposed structures. The same rains that had revealed the buried archaeology also posed a threat to its long-term survival. To protect the fragile mud brick structures and delicate frescoes from the elements, a large bioclimatic shelter was built over the entire archaeological site, allowing excavations to continue under controlled conditions while preserving the discovered remains. This protective roof, supported by 96 steel columns, is a key feature of the modern Akrotiri Archaeological Park. Since Marinatos' death in 1974, excavations have continued under the direction of Professor Christos Douma. Although only a fraction of the estimated 50-acre settlement has been uncovered, the discoveries continue to provide unprecedented insights into this ancient civilization. The irony of Akrotiri is that it was precisely the violence of its destruction that created the perfect conditions for its preservation, freezing a moment in time and giving us the clearest window we have into life in the Aegean Bronze Age. Chapter 7: Fire and Brimstone from the Sky. The biblical story of Sodom and Gomorrah has resonated through millennia as one of the most powerful narratives about divine destruction. According to the book of Genesis, these 2 cities were consumed by fire and brimstone from the sky due to their wickedness. For centuries, theologians and skeptics alike debated whether this was a moral allegory, a myth, or the distorted memory of a real event. It turns out the answer might be buried in the Jordan Valley. When Dr. Stephen Collins of Trinity Southwest University began excavations in 2005 at a site called Tal El Hammam, he was not necessarily looking for biblical Sodom. He was investigating an important Bronze Age urban center that seemed to fit the biblical description of the Jordan Plain. What he found was evidence of destruction that coincided disturbingly with the Genesis narrative. The connection between the biblical account and the archaeological findings is not just geographical. Genesis specifically describes how Abraham negotiated with God to save the cities if a certain number of righteous people were found within them. Finally, only Lot, Abraham's nephew, and his family were deemed worthy of salvation. They were warned to flee and not look back while God rained sulfur and fire, consuming Sodom and Gomorrah and the entire plain. The biblical description mentions specific details that, when examined through the lens of modern science, prove surprisingly consistent with a particular type of catastrophe: an atmospheric airburst of cosmic origin. Computer hydrocode simulations performed by the Comet Research Group modeled exactly this type of event. A Type 2 airburst, or touchdown, where the fireball reaches the Earth's surface, can generate exactly the type of high-velocity, high-temperature jet capable of creating the molten glass microspheres and multi-gigapascal shock metamorphism observed at the site. What makes this hypothesis particularly convincing is the presence of materials that simply shouldn't be there. Researchers found molten grains of platinum, iridium, nickel, gold, and silver distributed throughout the destruction layer. These noble metals, especially iridium, are extremely rare in the Earth's crust, but abundant in cosmic objects like asteroids and comets. The presence of diamondoids and other high-pressure crystalline carbon forms points to formation conditions requiring pressures and temperatures that are completely outside the range of any known terrestrial process. These materials typically form during hypervelocity impacts, when objects from space collide with Earth at velocities of tens of kilometers per second. But perhaps the most fascinating detail is how the physical evidence aligns with specific elements of the biblical narrative. The account mentions that Lot's wife was turned into a pillar of salt for looking back. In the context of a cosmic airburst, this takes on a different meaning. The event would have vaporized enormous amounts of salt from the nearby Dead Sea, creating a salt rain that would have been deposited over the region. Geochemical evidence supports this. Soil samples from the destruction layer show that anomalous salt concentration we mentioned earlier, but what we hadn't fully explained is how it got there. An airburst over the Dead Sea region would have created temperatures high enough to instantly vaporize brines and saline sediments, distributing them over a wide area. Genesis also describes how the land became desolate and infertile after the destruction. An airburst event of this magnitude would not only have sterilized the soil with extreme heat, but would also have saturated it with salt, making agriculture impossible for centuries. This perfectly explains why the region experienced that massive and prolonged abandonment we documented archaeologically. The chronology also fits surprisingly well. Carbon-14 dating of burned materials at the site provides a consistent age for the destruction layer that generally aligns with biblical chronologies for Abraham, though biblical chronologies are often debated among scholars. What makes this hypothesis scientifically intriguing is that it provides a single physical mechanism that can coherently explain all the diverse archaeological and geological evidence found at Tall el-Hammam. We're not talking about multiple separate events that coincidentally occurred. We're talking about a single high-energy event that can account for the extreme temperatures, shock effects, widespread physical destruction, disarticulated human remains, directional debris, and long-term regional environmental devastation. Proponents of the cosmic airburst theory have been careful to emphasize that their research focuses on physical evidence, not on validating or invalidating religious aspects of the biblical narrative. However, they have explicitly explored whether oral traditions about this catastrophic event might have served as the origin for the biblical account of Sodom's destruction in the book of Genesis. They point out that all the observations mentioned in Genesis are consistent with a cosmic airburst, fire from the sky, instant destruction, rain of burning materials, the conversion of a person into salt, and the long-term sterilization of the land. The cosmic airburst hypothesis at its core seeks to provide a single high-energy mechanism that can coherently explain all the diverse, seemingly disparate phenomena observed at Tall el-Hammam. It's an ambitious attempt to explain multiple separate phenomena with a single elegant solution, representing an ambitious scientific endeavor. The explicit, though controversial, connection with the biblical narrative of Sodom significantly amplified public interest and generated interdisciplinary discussion beyond traditional archaeological or geological circles. This has led to fascinating debates about how real catastrophic events can transform into religious and mythological narratives through generations of oral transmission. If the findings at Tal el-Hammam are indeed evidence of a city's destruction by a cosmic airburst, it suggests that while the specific moral and religious interpretations of the event in the Bible are matters of faith, the underlying physical catastrophe may have a basis in memory transmitted through generations. This raises profound questions about how many other mythical accounts of catastrophic destruction might have roots in real geological or cosmic events. The intensity and unusual nature of the destruction at Tal el-Hammam, as scientific analysis reveals, would have been undoubtedly perceived as a cataclysmic event by any survivors or witnesses, potentially leading to religious interpretations of divine judgment. Chapter 8. Alexandria, when fire followed water. On July 21st, 365 AD, the Eastern Mediterranean world experienced one of the most devastating tsunamis in recorded history. But what turned this natural disaster into a truly apocalyptic catastrophe was not just the wall of water that swept the coasts, but what came after: fires that transformed soaked cities into smoking infernos. Alexandria, the intellectual jewel of the ancient world, bore the brunt of it. The sequence of events began with a massive earthquake, estimated at magnitude 8.0 or higher, with its epicenter near the island of Crete. The force of the tremor was immense enough to cause widespread structural damage across a vast geographical area, extending from Greece to Egypt. Buildings collapsed, foundations cracked, and the ground itself buckled under the immense stress. Saint Jerome, the Christian scholar living at the time, described the devastation in vivid terms, noting how the earth groaned and trembled and how cities were swallowed by the sea. These early observations, though lacking the scientific precision of modern seismology, conveyed the scale of the disaster. But the earthquake was only the opening act of a two-part tragedy. Approximately 40 minutes after the initial tremor, something strange began to happen in Alexandria. The sea, which had been relatively calm, began to recede dramatically. This phenomenon, now understood as the trough of an approaching tsunami, exposed the muddy seabed dotted with lost cargo, shipwrecks, and harbor debris. The Alexandrians, unaware of what this sea retreat meant, were drawn to the exposed seabed. Some came to scavenge among the remains, others simply to witness the strange spectacle. It was a fatal curiosity. Moments later, the first of three massive waves generated by the same underwater seismic event rushed toward the estuary. Ammianus Marcellinus, the Roman historian who provided one of the most detailed and chilling accounts of the tsunami's impact on Alexandria, described how ships were hurled onto rooftops, how the sea transformed into a raging torrent, and how the bodies of the drowned covered the streets. The largest wave, estimated at up to 6 meters high in Alexandria, crashed into the city with unimaginable force. Buildings near the harbor were obliterated, ships were lifted from their moorings and carried inland, and countless lives were swept away. But here's where the story takes a particularly sinister turn. The tsunami didn't just bring water, it brought the perfect conditions for a massive conflagration. Alexandria, like most ancient cities, relied heavily on oil lamps for lighting. Houses were filled with olive oil stored in large ceramic jars. Artisan workshops contained flammable materials, from woods to textiles. When the tsunami's force overturned these lamps, broke storage jars, and dispersed fuels throughout already soaked buildings, it created a volatile mixture. The water itself, though it had soaked wooden structures, had been mixed with oils, perfumes, and other flammable materials that floated from destroyed workshops and warehouses. When flames finally ignited, they found abundant fuel despite the moisture. The marine winds that followed the tsunami fanned these initial fires. Air currents, altered by the atmospheric chaos created by the massive seismic event, carried flames from building to building. What had begun as isolated outbreaks quickly became a widespread fire that consumed entire districts of the city. The famous Library of Alexandria, though it had already suffered several previous fires and declines, lost more irreplaceable materials in this conflagration. Soaked scrolls became perfect kindling material once flames reached them. Knowledge accumulated over centuries turned to smoke in a matter of hours. The Serapeum, the magnificent temple dedicated to the god Serapis, was also partially destroyed. Its library, which had served as a branch of the Great Library, saw thousands of unique texts reduced to ashes. The intricate mosaics and sculptures that had taken decades to create were blackened by smoke or completely destroyed. The fires burned for days after the tsunami waters receded. Without organized fire services and with the city's infrastructure in ruins, there was no effective way to fight the flames. Survivors were forced to choose between risking their lives trying to save property or simply fleeing and letting the fire take its course. What makes Alexandria's destruction particularly tragic is what was lost. This wasn't just another coastal city, it was the intellectual nerve center of the Mediterranean world. It housed not only the world's most famous library, but also the museum, a research institution that attracted the best scholars from the entire known world. The long-term effects were devastating. The trade routes that had made Alexandria a prosperous center were disrupted. Agricultural lands were salinized by the saltwater flooding, making agriculture impossible for years. Countless communities were displaced, creating waves of instability that spread throughout the region. But perhaps most significant was the psychological blow. Alexandria had been seen as a permanent, eternal city, a beacon of civilization that had withstood conquests, political changes, and minor natural disasters for centuries. Seeing its destruction so swift and complete shook people's confidence in the stability of their world. Modern geologists have found compelling evidence corroborating these ancient accounts. Sedimentary layers containing marine deposits found far inland from the current coastline in regions like Crete and Egypt provided irrefutable proof of a massive flooding event. These layers, often characterized by a chaotic mixture of sand, shells, and marine debris, were distinct from normal alluvial or aeolian deposits. Analysis of these layers also revealed evidence of ash and charcoal mixed with the tsunami sediments, confirming that fires indeed followed the flooding. The presence of these burned materials within the tsunami deposits tells the story of a city that was not only flooded, but also burned, a double catastrophe that enormously amplified the destruction. Chapter 9: The Greek Atlantis that burned beneath the waters. In the year 373 before Christ, Helike was one of the most prosperous cities in Greece. Located on the southern coast of the Gulf of Corinth, it was a leading member of the Achaean League, a powerful confederation of city-states. Its fame extended far beyond its immediate borders, particularly for its revered temple of Poseidon Helikonios, a sanctuary so significant that it attracted pilgrims and supplicants from throughout the Greek world. But Helike's days of glory were numbered, and the warning signs had been appearing for weeks. The first hints that something was wrong came in the form of a massive animal exodus. Mice, snakes, and other creatures were seen abandoning the city en masse, fleeing to higher ground. This phenomenon, often interpreted as a sign of impending natural disaster, went unnoticed by the human inhabitants, who perhaps attributed it to unrelated phenomena or simply dismissed it as peculiar behavior. But the animals knew something the humans did not. The earth beneath Helike had been building up tension for years, and it was about to release it in the most violent way possible. What makes Helike's story particularly interesting from the perspective of our theme of destructive fire is that fires played a significant role in the events preceding the final disaster. Historical records suggest that the city had experienced a series of minor fires in the months leading up to its final destruction. These fires were not unusual for an ancient Greek city. Houses were built primarily of wood with thatched or clay tile roofs. Lighting was provided by oil lamps, and heating came from braziers burning charcoal or wood. Accidents were common. An overturned lamp escaping embers from a brazier or even lightning during storms could easily ignite vulnerable structures. But what turned these seemingly routine fires into ominous omens was their increasing frequency. and intensity. The small earthquakes that had been shaking the region had also been overturning lamps and braziers regularly. Each minor tremor brought with it the risk of multiple simultaneous fires throughout the city. Helik's inhabitants had grown accustomed to these minor fires. They had developed routines for dealing with them, systems for fighting flames quickly before they could spread. What they didn't realize was that these fires were symptoms of something much larger and more terrifying approaching. Then, on the night of disaster, everything changed. A massive earthquake struck, much more powerful than any of the minor tremors the city had experienced. The ground beneath Helika convulsed violently, tearing apart buildings and causing widespread destruction. The tremors were so severe they were felt throughout the entire Peloponnese, shaking cities and settlements kilometers away. But the earthquake was only the prelude to an even more terrifying force. Immediately after the seismic shock, the sea, which moments before had been calm, began to behave unnaturally. A colossal tsunami generated by the underwater displacement caused by the earthquake rushed inland with unimaginable speed and power. The wave, described as immense in height, swept over Helik, engulfing the entire city and its surrounding plain. The water's force was so overwhelming that it dragged buildings, trees, and people into the turbulent depths. Within hours, Helike, along with the neighboring city of Bura, was completely submerged. Accounts state that not a single inhabitant survived and the city simply vanished beneath the waves, leaving no trace on the surface. For centuries afterward, fishermen sailing over the area claimed to see the submerged ruins of Helike, its temples and statues visible through the clear waters, a ghostly reminder of the city that had been swallowed by the sea. The modern search for Helike began in earnest in the late 20th century, driven by the persistent efforts of a dedicated team of archaeologists and scientists. Among the most prominent figures in this effort were Dora Katsonopoulou, a Greek archaeologist, and Stephen Soter, an American astronomer and geologist. Their collaboration, initiated in the 1980s, marked a systematic and interdisciplinary approach to solving the ancient mystery. They understood that finding Helike would require more than just traditional archaeological excavation. It would need a deep understanding of the geology, seismicity, and coastal geomorphology of the region. Their initial research focused on meticulously re-examining ancient texts, not just for direct mentions of Helike, but for subtle clues about the local environment, the nature of the catastrophe, and subsequent changes to the coastline. They also delved into historical maps and geological studies, attempting to reconstruct the ancient landscape and identify areas where subsidence might have occurred. A crucial aspect of their methodology involved seismic profiling, a technique typically used in oil and gas exploration, adapted for archaeological purposes. This involved sending sound waves into the ground and recording the echoes, which could reveal subsurface structures and geological layers. The breakthrough in the search for Helike came in the late 1980s and early 1990s. In 1988, initial seismic studies revealed anomalous subsurface structures in the Helik Plain, suggesting the presence of buried archaeological remains. These findings encouraged more specific and targeted investigations. By 1994, the team now known as the Helike Project had narrowed down a promising area. It was not under the sea in the traditional sense, but rather beneath the modern alluvial plain, several kilometers inland from the present coastline. This seemingly paradoxical location was a testament to the dramatic geological changes that had occurred since 373 BC. The land had subsided significantly during the earthquake, and subsequent riverine deposition had built up the plain, effectively burying the ancient coastal city under land. Then, in the year 2000, a truly definitive discovery was made. Archaeologists unearthed a significant portion of a classical city, including walls, roads, and pottery fragments, all perfectly preserved under layers of sediment. The pottery in particular provided crucial dating evidence, confirming that the site was indeed from the classical period, aligning with the time of Helik's destruction. Even more convincing was the discovery of coins minted in Helik, bearing the distinctive image of Poseidon, the city's patron deity. These artifacts provided irrefutable proof that they had indeed located the legendary lost city. What was even more interesting to scientists was the unique state of preservation of the ruins. Unlike many ancient cities that have been destroyed by earthquakes and subsequently rebuilt or looted, Helike was sealed almost instantly by the combination of liquefaction and the tsunami. Liquefaction, a phenomenon where saturated granular material like sand or silt temporarily loses its strength and behaves like a liquid due to seismic shaking, caused the ground beneath Helike to lose its load-bearing capacity. Buildings would have sunk into the liquefied ground, and then, when the soil solidified again, they were encased in a protective layer of sediment. The subsequent tsunami then deposited more layers of fine silt and clay, effectively creating an anaerobic environment that prevented decomposition and preserved organic materials that would normally decay. This geological time capsule meant that the city was not merely destroyed, but entombed, offering an incomparable view of ancient life frozen at the moment of catastrophe. Chapter 10. The Fire That Changed China's Destiny. Approximately 4,000 years ago, in the plains of northern China, the Yellow River meandered through a landscape that had been shaped by millennia of silt deposition. This river, known as Huanghe, had earned the sinister nickname China's Sorrow due to its propensity for devastating floods and dramatic course changes. But nothing in its recorded history compared to what was about to happen. The story begins not with water, but with fire. For years before the mega flood that would change a civilization's fate, the region had experienced prolonged droughts. Paleoclimatic records and sediment core analysis reveal a period of extreme aridity that had lasted for decades. The forests that once covered the surrounding mountains had dried to perfect tinder. And then came the forest fires. These were not controlled burns or minor fires. They were massive conflagrations that devoured entire mountains, leaving hillsides completely bare. The resulting deforestation was catastrophic because it eliminated the root system that had been holding soil in place for millennia. Without this network of roots to stabilize the earth, the mountain slopes became extremely vulnerable to erosion. When the rains finally came after years of drought, they found a landscape that could no longer contain them. Water rushed down the bare slopes, picking up enormous amounts of loose sediment and debris. But this was only the beginning of a chain of events that would culminate in one of the most destructive floods in human history. The critical point came at Jishi Gorge, approximately 25 kilometers upstream from the archaeological site of Lajia. Here, the combination of fire-weakened debris and intense precipitation triggered a landslide of epic proportions. The material that tumbled from the steep valley walls was so massive that it created a natural earthen dam that effectively dammed the Yellow River. Scientists who have studied the geological evidence of this event, including a team led by Wu Qinglong of Beijing University, calculate that this natural dam was approximately 200 meters high. To put this in perspective, that's higher than many major modern dams. The Hoover Dam, for example, is 221 meters high. The water impounded behind this natural barrier would have accumulated over a period, forming a lake that extended for hundreds of kilometers upstream. The volume of water contained by this temporary dam would have been enormous, creating immense pressure on the natural barrier. Geological calculations indicate that this dam eventually failed catastrophically. Once the water was released, it rushed downstream in a massive breach flood. Scientists calculated that the flood waters released from the Jishi Gorge Dam would have traveled at speeds of up to 200 to 300 meters per second, carrying an estimated 12 to 16 cubic kilometers of water. This volume is comparable to the largest dam break floods known on Earth, such as the Missoula floods that shaped the Pacific Northwest landscape in North America. But unlike those prehistoric floods that occurred in relatively unpopulated areas, this Chinese mega-flood struck directly at thriving civilizations. Evidence of what happened to these civilizations can be seen at the archaeological site of Lajia, often called the Pompeii of China. Excavations here have revealed a snapshot of Bronze Age society, tragically buried by sudden catastrophe. What makes Lajia particularly fascinating is the preservation of domestic scenes that were abruptly interrupted. In 2005, during excavations at Lajia, archaeologists discovered a well-preserved bowl of noodles, carbon dated to approximately 4,000 years ago. The bowl, found overturned as if someone had been eating when disaster struck, suggested an abruptly interrupted meal. This discovery pointed to a sudden catastrophic event. Archaeologists also found human skeletons trapped in collapsed dwellings, indicating rapid and unexpected death. The site's stratigraphy revealed distinct layers of flood sediments, characterized by thick layers of dark, silty clay, distinct from the usual lowest deposits. These sediments contained fragments of human bone and pottery, further indicating their association with the settlement's destruction. Scientists observed that the flood deposits thinned and became less destructive further downstream from Jishi Gorge, suggesting a powerful localized event that gradually dissipated. The dating of this geological event was crucial for linking it to the myth of Yu's Great Flood. Carbon-14, dating of organic material within the flood sediments at Lajia, as well as human remains found in the flood deposits, yielded a consistent age of approximately 3,900 to 4,000 years ago. This time frame aligns remarkably well with the traditional chronology for the beginning of the Saya dynasty, often placed around 2000 BC. The synchronicity between geological evidence of a mega-flood and the mythical period of Yu's flood control efforts provides a tantalizing connection between legend and geological reality. According to traditional Chinese accounts, the Great Yu was the legendary hero who finally controlled these devastating waters. But what makes Yu's story particular is his approach to the problem. While his father Gun had tried to contain the waters by building dikes and barriers that ultimately proved useless against the immense pressure, Yu adopted a strategy of dredging, channeling, and guiding the waters, allowing them to flow naturally to the sea. Yu is said to have spent 13 years on this monumental task, traveling the land, personally inspecting the terrain, and directing the construction of channels and ditches that would carve new paths for the river, draining the flooded lands. The scale of this enterprise, as described in texts like the Shujing, Book of Documents, and Sima Qian's records of the Grand Historian, is truly astonishing. Yu is portrayed as a selfless leader, so dedicated to his work that he passed by his own home 3 times without entering, even when his wife gave birth. His success in bringing order to the flooded realm is presented as the ultimate legitimizing factor for his rule, marking a pivotal transition from tribal society to a more centralized dynastic state. The myth attributes to Yu the division of China into the 9 provinces, a geographical and administrative framework that reflected the newly drained and organized land. This narrative has profoundly shaped Chinese identity, emphasizing the importance of collective effort, engineering prowess, and a harmonious relationship with nature. The domestication of the Yellow River in this legendary context was not merely an engineering feat, but a civilizing act, transforming a chaotic wasteland into a habitable and cultivable realm. However, the question of whether this epic flood and Yu's heroic efforts are purely mythical or have roots in geological truth has long fascinated historians and scientists alike. If the Jishi Gorge breach flood is indeed the geological event that inspired the myth of Yu's Great Flood, it suggests that the myth, though embellished with heroic details, has a factual basis in a real catastrophic natural disaster. Such an event would have been transformative for early Chinese societies, not only due to the physical destruction it caused, but also due to the massive organizational responses it would have required. The magnitude of the challenge would have necessitated unprecedented centralized leadership, cooperation among scattered communities, and large-scale engineering innovations. In this sense, the megaflood may have indeed been the catalyst that pushed Chinese society from fragmented tribal organizations toward the first forms of unified dynastic government. Chapter 11. The Hidden Pattern, when Earth decides to start over. After traveling through millennia and continents, from the plains of Pakistan to the coasts of Jamaica, from the slopes of Vesuvius to the depths of the Mediterranean Sea, a pattern emerges that is as unsettling as it is revealing. We are not talking about isolated events or historical coincidences. We are seeing something much more systematic, something that suggests catastrophic destruction has been a constant force in human history. The first thing that jumps out when you examine these events side by side is the similarity in temperatures. Mohenjo-daro, over 1,500 degrees Celsius. Tall El Hammam, exceeding 2,000 degrees. Herculaneum, between 400 and 500 degrees from pyroclastic flows. These are not temperatures you can achieve with ordinary fires or even with the conventional warfare of the time. For clear reference, copper melts at 1,085 degrees, iron at 1,538 degrees. We are talking about events that generated enough heat to melt metals, turn bricks to glass, and vaporize organic matter instantly. And this happened in civilizations separated by thousands of years and thousands of kilometers. But temperatures are only the beginning. What really catches attention is the selective preservation. In each case, the extreme conditions that destroyed these civilizations also created unique preservation environments. Herculaneum was sealed by volcanic mud that carbonized organic materials. Port Royal was submerged in anoxic conditions that kept wooden furniture and leather shoes intact. Akrotiri was buried under volcanic ash that preserved frescoes with colors so vivid they seemed to have been painted yesterday. It's as if these catastrophic events had been designed not just to destroy, but to create perfect time capsules. The same violence that erased these civilizations from the map also immortalized them in ways their original builders could never have imagined. Through their destruction, they became windows into lost worlds, reminders that even in the most complete annihilation, something always survives. And perhaps that's the final lesson, that even when everything seems lost, even when fire has consumed everything we know, history finds a way to preserve what matters. In carbonized ashes, in molten glass, in preserved skeletons and stories transmitted through generations, the past persists, waiting to be rediscovered by those who have eyes to see and tools to understand. Then there's the question of speed. In each case, we're seeing instantaneous or near-instantaneous destruction. Mohenjo-daro, bodies frozen mid-motion. Tall El Hammam, complete disarticulation of skeletons. Port Royal, a clock stopped exactly at 11:43. Herculaneum, people vaporized before they could even try to escape. This rapidity is fundamentally different from what you would expect from wars, epidemics, or even most natural disasters. Wars leave evidence of prolonged conflict. Epidemics show patterns of gradual death. Even typical earthquakes give people time to run to doorways or seek shelter. But these events were so fast that people literally had no time to react. And here's where things get really interesting from a scientific perspective. The technological advances of the 21st century have given us tools that previous generations of archaeologists didn't have. We can detect microdiamonds that form only under extreme pressures. We can analyze isotopes that reveal precise temperatures. We can use X-ray tomography to read scrolls that have been carbonized for 2,000 years without even touching them. These technologies are revealing evidence that simply couldn't be detected before. The shocked quartz crystals at Tall El Hammam, the vitrified brain matter at Herculaneum, the extraterrestrial noble metals scattered through destruction layers. Each of these findings is forcing us to reconsider what we thought we knew about these events. But perhaps most fascinating is what these discoveries tell us about the relationship between historical memory and geological reality. For centuries, accounts like the destruction of Sodom and Gomorrah were dismissed as myths or moral allegories. Now we're finding physical evidence that matches disturbingly well with these ancient accounts. This raises profound questions about how many other legends might be based on real events. Plato's Atlantis story, for example, has surprising parallels to what happened to Helike. The universal flood described in traditions worldwide could be reflecting distorted memories of events like Yu's megaflood in China. What we're seeing is how traumatic events transform as they pass from generation to generation. Specific details are lost or exaggerated, but the emotional core, the psychological impact of sudden and inexplicable destruction, remains intact, and it's this core that eventually crystallizes into myths and religious accounts. From a geological perspective, these events are teaching us that our planet is much more violent and unpredictable than we generally assume. Most people think of geological changes as gradual processes that happen over millions of years. But these sites show us that Earth can also change instantly, with violence that can erase entire civilizations in minutes. Some of these events have clear explanations. Volcanoes like Vesuvius and Thera follow well-understood patterns of magmatic activity. Earthquakes like those that destroyed Lisbon and Port Royal result from tectonic plate movements that we can map and, to some extent, predict. But other events, particularly those involving extreme temperatures, without an obvious volcanic source, remain mysterious. Cosmic airburst theories offer possible explanations, but they remain controversial. What isn't controversial is the physical evidence of temperatures and pressures that go beyond what should be possible with ancient technology. This brings us to a disturbing question. How vulnerable are we today? Our modern cities are much larger and denser than anything that existed in the ancient world. We have interconnected infrastructure systems that could cascade fail. We depend on technologies that are susceptible to electromagnetic disruptions. At the same time, we have monitoring capabilities that ancient civilizations didn't have. We can track volcanic activity, detect approaching asteroids, and predict many types of natural disasters with days or even weeks of advance notice. But as these ancient sites show us, some events can develop faster than any early warning system can handle. Perhaps the most important lesson from these sites is not about physical vulnerability, but about psychological resilience. Each of these civilizations thought it was permanent, stable, immune to catastrophic destruction. The inhabitants of Mohenjo-Daro had built the world's most sophisticated planned city. The citizens of Alexandria controlled the largest library in human history. The residents of Port Royal had accumulated wealth that rivaled that of any city on Earth. And yet, in a matter of minutes or hours, everything disappeared. This doesn't mean we should live in fear or that progress is useless. It means we should maintain a humble perspective about our place in the cosmos. It means we should value what we have while we have it. And it means we should remember that history is not a straight line of progress, but a complex cycle of construction, destruction, and renewal. In the end, these sites teach us that destruction and preservation are two sides of the same coin. The same events that erased these civilizations from the map also immortalized them in ways their original builders could never have imagined. Through their destruction, they became windows into lost worlds, reminders that even in the most complete annihilation, something always survives. And perhaps that's the final lesson, that even when everything seems lost, even when fire has consumed everything we know, history finds a way to preserve what matters. In carbonized ashes, in molten glass, in preserved skeletons and stories transmitted through generations, the past persists, waiting to be rediscovered by those who have eyes to see and tools to understand. Chapter 12. The Scientific Revolution that is rewriting history. In the last 2 decades, something extraordinary has been happening in research laboratories all over the world. Technologies that barely existed when we began excavating these ancient sites are revealing secrets that have been hidden for millennia. It's not just about better excavation tools or more precise dating techniques. We are talking about a complete revolution in how we can read the archaeological record, detect evidence that was completely invisible to previous generations of scientists. And what we are finding is forcing textbooks to be rewritten, established chronologies to be reconsidered, and possibilities that until recently would have been dismissed as science fiction to be confronted. Let's start with something that would seem impossible: reading a book that was reduced to charcoal 2,000 years ago without even touching it. In the year 2000, when researchers at the California Institute of Technology first applied X-ray phase contrast tomography to the carbonized Herculaneum scrolls, the archaeological world held its breath. These scrolls, which had been mistaken for logs of wood when first discovered in the 18th century, contained the only intact library from the Roman world. But they were so fragile that touching them turned them immediately into dust. The technology works by detecting microscopic differences in the density of materials. The ink, made from carbon-based materials, provides enough contrast against the carbonized papyrus to be detected by these specific imaging techniques. What the researchers discovered was that the carbonization process had preserved not only the papyrus, but also the molecular structure of the ink in a way that allowed virtual reading. The first completely unrolled scroll revealed texts by the Epicurean philosopher Philodemus that had been lost for 2 millennia. But this was just the beginning. The technique has improved dramatically since then, and now researchers can not only read text but also detect multiple layers of writing, corrections, and even fingerprints of ancient scribes. Dr. Brent Seals of the University of Kentucky, who has led many of these efforts, describes the process as information archaeology. They are not excavating physical objects, but layers of knowledge that have been preserved in ways we could never access before. But the imaging revolution is only part of the story. Isotopic analysis techniques have opened completely new windows onto the past. When researchers analyze the isotopes of carbon, oxygen, and other elements in ancient materials, they can determine not only when events occurred, but also the exact conditions under which they occurred. At Tal el Hammam, the isotopic analysis of melted materials revealed signatures consistent with temperatures exceeding 2,000 degrees Celsius, but it also revealed something else: the presence of isotopes normally associated with extraterrestrial processes. The specific ratios of certain elements match what we find in meteorites, not what we would expect from normal terrestrial processes. Dr. James Kennett of the University of California, Santa Barbara, who has pioneered the use of these techniques to study ancient impact events, explains that each catastrophic event leaves a unique isotopic signature in the geological record. It's like a chemical fingerprint that tells us not only that something happened, but exactly what kind of physical process was involved. In recent years, these techniques have been applied to sites all over the world, and the results have been astonishing. The vitrified forts of Scotland, long explained as the result of unique Celtic construction techniques, show isotopic signatures suggesting temperatures and conditions far beyond what any Iron Age technology could have produced. In India, the analysis of the vitrified ruins near Jodhpur has revealed anomalous concentrations of rare earth elements normally only found at meteorite impact sites. In Peru, the seemingly melted stones of some Inca sites show evidence of isotopic alteration suggesting exposure to intense radiation fields. But perhaps the most surprising revelation has come from the analysis of ice cores from Greenland and Antarctica. When scientists examine ice layers corresponding to the time periods of these destructive events, they find spikes in the concentration of elements normally only seen after cosmic impacts or massive volcanic eruptions. Dr. Mukul Sharma of Dartmouth College has been studying these ice cores for over a decade. His work has revealed that there are multiple layers in the polar ice containing evidence of catastrophic events that do not appear in any human historical record. These layers show sudden spikes in elements like iridium, platinum, and other platinum group metals that are extremely rare in the Earth's crust, but common in cosmic objects. What makes this particularly intriguing is the temporal distribution of these events. They are not randomly distributed through time. There are periods where multiple events seem to have occurred in relatively rapid succession, followed by long periods of relative calm. This has led some researchers to propose that our solar system periodically passes through regions of space with higher cosmic debris density. The theory suggests that our solar system's orbit around the galactic center takes us through different cosmic neighborhoods, some of which contain more asteroids, comets, and other potentially hazardous objects. Dr. William Napier of Cardiff University has developed computer models suggesting that these periods of increased cosmic activity could occur in cycles of several thousand years. If this is correct, it would mean that the catastrophic events we have been studying are not random occurrences, but part of a larger pattern operating on timescales beyond recorded human experience. But the technological revolution is not limited to the analysis of ancient sites. It is also transforming our ability to detect and prepare for future events. Asteroid detection systems have improved dramatically in recent years. The Catalina Sky Survey, Linear, and other projects have cataloged tens of thousands of near-Earth objects that were previously completely unknown. What they have found is both reassuring and alarming. Reassuring because most of the really large objects, those capable of causing global extinction, have been identified and tracked, and none are on a collision course with Earth in the foreseeable future. Alarming because there are far more medium-sized objects, those capable of causing regional devastation like what we saw at our ancient sites, than previously thought. The Chelyabinsk event in 2013, where an approximately 20-meter asteroid exploded over Russia, gave us a glimpse of what smaller events can do. The explosion was equivalent to about 30 Hiroshima bombs, shattered windows over a 200-kilometer radius, and injured over 1,000 people. And this was from an object too small to be detected by our current surveillance systems. If an object just 5 times larger had impacted a populated area, the result would have been devastation comparable to what we saw in our archaeological sites. And objects of this size strike Earth roughly once every several hundred years, according to current estimates. This has led to an unprecedented international effort to improve our detection and defense capabilities. NASA's DART mission, which successfully altered an asteroid's orbit in 2022, demonstrated that we have the technology to deflect potentially hazardous objects if we detect them early enough. But perhaps more importantly, we are developing systems that can distinguish between different types of cosmic threats. Not all objects approaching Earth are solid rocks. Some are comets, composed mainly of ice and organic materials. Others are metallic asteroids rich in iron and nickel. And some are what scientists call rubble piles, loose collections of smaller rocks held together by gravity. Each type of object behaves differently when entering our atmosphere. Comets tend to disintegrate at higher altitudes, creating dramatic visual spectacles but less damage on the surface. Rocky asteroids can penetrate deeper into the atmosphere before exploding. Metallic asteroids are the most dangerous because they can survive the atmospheric passage and actually impact the surface. Dr. Peter Brown of the University of Western Ontario has been studying these differences for years, using data from infrasound stations that can detect the shock waves from atmospheric explosions thousands of kilometers away. His work has revealed that we are being hit by small objects far more frequently than previously thought, but that most disintegrate so high in the atmosphere that they go unnoticed. However, his data also show that occasionally larger objects penetrate much deeper into the atmosphere, creating shock waves that can cause significant damage on the surface. These events, which scientists call superbolides, occur roughly once every few decades, but their effects can be devastating for anything in the immediate impact area. When you combine this information with the archaeological evidence we have been exploring, a disturbing picture emerges. The events that destroyed sites like Tal el-Hammam were probably not unique in human history. They were simply the ones that occurred in places and times where preservation conditions were perfect for preserving the evidence until we had the technology to recognize it. This suggests that there may be dozens, perhaps hundreds, of similar sites waiting to be discovered. Places where thriving civilizations were wiped off the map by cosmic events, but where conditions were not suitable for preserving the evidence so dramatically. In fact, some researchers are beginning to use the isotopic signatures we have identified at known sites as search tools to find new sites. Dr. Alan West, a member of the Comet Research Group, has developed techniques to search for the characteristic microspherules and nanodiamonds from impact events in sediment samples from all over the world. His preliminary work has identified potential impact sites in North America, Europe, and Asia that have not been fully excavated. Some of these sites show evidence of having been occupied by humans at the time of the impact event, suggesting they may preserve evidence of civilizations that were destroyed in ways similar to what we have seen in our case studies. But the scientific revolution is also revealing information about extreme volcanic events that go beyond anything in our modern experience. The analysis of sediment cores from the ocean floor has identified multiple layers containing evidence of volcanic eruptions that dwarf even the largest events in recorded history. The Toba eruption 74,000 years ago, for example, was approximately 100 times larger than any volcanic eruption in human memory. It injected so much material into the atmosphere that it likely caused a volcanic winter lasting years. Some scientists believe this event nearly drove the human species to extinction, reducing the global population to just a few thousand individuals. But sediment cores show evidence of multiple events of this scale over the last few 100,000 years. And some of these extreme volcanic events show features that are difficult to explain using our current understanding of normal volcanic processes. Dr. John Grattan of Aberystwyth University has been studying the effects of historical volcanic events on human civilizations. His work has shown that even relatively minor eruptions can have devastating effects on societies dependent on agriculture. The Laki eruption in Iceland in 1783, for example, caused famines that killed a quarter of Iceland's population and contributed to the conditions that led to the French Revolution. But when Grattan examines the evidence for extreme volcanic events from the past, he finds evidence of effects going far beyond what any modern eruption has produced. Some of these ancient eruptions seem to have generated surface temperatures high enough to melt rock, not only in the immediate area around the volcano, but at distances of hundreds of kilometers. This has led some scientists to propose that there may be types of volcanic activity we have not observed in modern times, eruptions involving not only the expulsion of magma, but also the release of energy stored in forms we do not fully understand. The most speculative theory suggests that certain types of volcanic eruptions could trigger chain reactions releasing energy from non-volcanic sources. Some researchers have proposed that under certain geological conditions, volcanic activity could trigger the release of energy stored in methane hydrate deposits or even in crystalline structures in the Earth's crust. These ideas remain highly speculative, but they are representative of how evidence from extreme events of the past is pushing scientists to consider possibilities that would previously have been dismissed as impossible. Perhaps the most exciting development in this field is the application of artificial intelligence and machine learning to the analysis of archaeological and geological data. Researchers are using algorithms to search for patterns in massive datasets that would be impossible to detect through traditional human analysis. Dr. Tim Kohler of Washington State University has been using these techniques to analyze patterns in the archaeological record that might indicate catastrophic events that have not been previously recognized. His preliminary work has identified multiple periods in human history where populations declined suddenly across broad regions, suggesting events that affected multiple civilizations simultaneously. What makes this approach particularly powerful is its ability to detect subtle patterns that might be missed when studying individual sites in isolation. When you examine a single archaeological site, it might look like a particular civilization simply went into gradual decline. But when you look at the broader picture across multiple sites, you can sometimes see that multiple civilizations across a wide region experienced sudden changes at the same time. This is exactly what researchers are finding when they apply these techniques to data from sites in the Eastern Mediterranean, the Middle East, and parts of Asia. There are multiple periods where civilizations that had no direct contact with each other all experienced major disruptions at roughly the same time. The period around 1200 BC, known to archaeologists as the Late Bronze Age collapse, is a particularly dramatic example. Within just a few decades, the Hittite Empire disintegrated, Mycenaean palaces were abandoned, Canaanite cities were destroyed, and Egypt itself was attacked by mysterious sea peoples. For decades, archaeologists have debated what caused this seemingly coordinated collapse of civilizations across a vast region. Theories have included everything from climate change to invasions to civil wars. But the AI analysis of archaeological data is revealing patterns that suggest something more dramatic may have been involved. The algorithms are detecting signatures in the archaeological record that are consistent with multiple catastrophic events occurring in rapid succession. Not a single event affecting the entire region, but a series of events striking different areas during a concentrated period of time. This information, combined with ice core data showing multiple spikes of impact-associated elements during the same period, is leading some researchers to propose that the Late Bronze Age collapse may have been caused by a swarm of cosmic impacts, not a single large asteroid or comet, but multiple smaller objects striking Earth over a relatively short period. If this is correct, it suggests that these types of multiple impact events could be more common than previously thought. And if our solar system does indeed pass through regions of space with higher cosmic debris density, we might be entering another of these periods. This possibility has led to an unprecedented international effort to improve our detection and preparedness capabilities. NASA's Planetary Defense Program, established in 2016, is working not only to detect potentially hazardous objects, but also to develop technologies that could protect us from multiple simultaneous threats. But perhaps most importantly, this scientific revolution is fundamentally changing how we think about human history. We can no longer assume that the development of civilization has been a linear process of gradual progress, occasionally interrupted by wars or minor natural disasters. Instead, we are beginning to see that human history has been shaped by catastrophic events occurring on timescales and with intensities beyond our modern experience. These events have acted as evolutionary resets, wiping out entire civilizations but also creating opportunities for new forms of social organization and technological development. This perspective has profound implications for how we think about our own future. It suggests that we should be prepared not only for the kind of gradual challenges we can foresee and plan for, but also for sudden extreme events that might require completely new forms of social and technological organization. But it also suggests that we are more resilient than we might think. The human species has survived multiple catastrophic events in the past, and not only survived, but used those events as catalysts for innovation and growth. The sites we have explored are not just stories of destruction, they are stories of preservation, of knowledge surviving even the most extreme events, of civilizations finding ways to transmit their achievements through time, even when they themselves were destroyed. And now, armed with technologies that allow us to read these preserved records with unprecedented clarity, we are finally beginning to understand the message that these past civilizations have been trying to send us across millennia. That destruction and creation are part of the same process, that endings are also beginnings, and that the fire that consumes also illuminates the way forward. Chapter 13. The Legacy of the Ashes. We have traveled through 4,000 years of human history, from the sophisticated streets of Mohenjo-Daro to the luxurious salons of Port Royal, from the slopes of Vesuvius to the depths of the Mediterranean. At every stop, we have witnessed something that challenges our fundamental understanding of what is possible. We have seen entire civilizations wiped off the map in minutes, temperatures rivaling the core of stars, and destruction so complete it transcends anything war or nature should be able to achieve. But perhaps the most disturbing thing of all is that these events are not isolated historical aberrations. They are part of a pattern extending far beyond the cases we have explored. In Jericho, the walls didn't just fall, they show evidence of vitrification similar to what we find at other sites. In the hill forts of Scotland and Ireland, massive stone structures were melted into vitreous masses locals call vitrified forts. In Australia, the desert is dotted with what geologists call fulgurites, natural glass formed when lightning strikes sand, but in quantities and distributions suggesting events far more massive than ordinary thunderstorms. In Peru, the stones of Sacsayhuaman are not only cut with impossible precision, but some show signs of having been partially melted and re-solidified. In India, the ruins of Raj Mahal show bricks fused in patterns conventional archaeologists have struggled to explain for decades. And then there are the sites we haven't even begun to fully understand. In the Libyan desert, there is a type of natural glass called Libyan desert glass formed uniquely under extreme temperatures. Geologists have debated for years whether it was formed by a meteorite impact or some other unknown process. What they don't dispute is that something generated temperatures of over 1,700 degrees Celsius across an area spanning thousands of square kilometers. In Brazil, there is a region known as Serra da Capivara that contains rock art that seems to depict figures with helmets and what appear to be explosions or fires in the sky. Archaeologists have dated these paintings as thousands of years old, long before humans had the technology to create the scenes they seem to be describing. Even in North America, there is disturbing evidence. The glass from Crater Lake in Oregon formed under conditions beyond what normal volcanic activity should be able to produce. In the Great Lakes, there are sediment deposits containing microspherules similar to those we found at Tal El Hammam, but in layers dating back 12,000 years, coinciding with the end of the Ice Age. What all these sites have in common is that they represent events that are at the very limit of what our current scientific framework can explain. They are not impossible, but they require conditions so extreme that they force us to reconsider our assumptions about the stability of the natural world. And here is where things get really interesting from a modern perspective. We live in a time when we have the technology to create our own extreme temperatures. Our thermonuclear weapons can generate heat rivaling the interior of the sun. Our experimental fusion reactors are creating conditions that exist naturally only in stars. Our particle accelerators are generating pressures that normally require the gravitational collapse of entire planets. In other words, for the first time in human history, we have the technological capacity to create the kind of destruction we see at these ancient sites. This raises a disturbing question. Are we the first to reach this level of destructive capability, or are we simply rediscovering knowledge lost when previous civilizations were wiped off the map? The conventional answer, of course, is that we are unique, that our industrial and scientific revolution is unprecedented in human history, that any similarity between ancient destruction and modern capabilities is purely coincidental, but the physical data tells a different story. Isotopes do not lie. Shocked quartz crystals do not form under normal conditions. Microdiamonds require specific, well-understood pressures, and these signatures are present at sites all over the world in layers dating to different historical periods. What this suggests is not necessarily that ancient civilizations had nuclear or laser technology. What it suggests is that events have occurred in human history that generated physical conditions equivalent to those technologies, either through extreme natural phenomena we do not fully understand, or through technologies that were lost along with the civilizations that created them. From a purely scientific perspective, some of these events can be explained through known natural mechanisms. Cosmic airbursts are real, well-documented phenomena. The Tunguska event in 1908 demonstrated that relatively small objects from space can release energy equivalent to hydrogen bombs. Supervolcanoes like the one that created Lake Toba 74,000 years ago can generate devastation on a global scale. But even these known natural mechanisms require a frequency of catastrophic events that is at odds with our modern observations. If cosmic airbursts were responsible for the destruction we see at sites like Tal el-Hammam, then we should be seeing similar events regularly in modern times. If extreme volcanic activity was responsible for sites like Mohenjo-Daro, then we should have evidence of eruptions far beyond anything in the recent geological record. This leads us to one of the most unsettling possibilities, that the Earth itself goes through cycles of activity beyond our recorded experience. That there are geological or cosmic processes operating on timescales beyond our direct observation, but which have been responsible for repeated catastrophic events throughout human history. Some scientists have proposed that our solar system periodically passes through regions of space with higher cosmic debris density, which would result in an increase in the frequency of impacts and airbursts. Others have suggested that the Earth's magnetic field goes through periods of weakening that make us more vulnerable to cosmic radiation and solar particle events. There are even more speculative theories suggesting the galaxy itself has cycles affecting the stability of planetary systems, that there are forces operating on scales we are only beginning to understand, and that these catastrophic events are simply local manifestations of much larger cosmic processes. But regardless of what the ultimate explanation is, what is clear is that these events have had a profound impact on the course of human civilization. Each time an advanced society has been destroyed, knowledge has been lost, techniques have been forgotten, traditions have been broken, and yet somehow humanity has always found a way to recover, to rebuild, to move forward. Each of these catastrophes has been followed by periods of cultural and technological renewal. It is as if destruction itself were a catalyst for innovation. Consider the pattern. Mohenjo-Daro was destroyed, but the Indus Valley civilization eventually gave way to new cultures that inherited and developed its innovations in urban planning and water management. Akrotiri was buried, but Minoan civilization profoundly influenced the development of classical Greece. Herculaneum was incinerated, but the scrolls it preserved are providing new insights into ancient philosophy that are informing modern thought. Even Port Royal, despite its sinister reputation, was a crucial center of commercial and navigational innovation that helped shape the modern Atlantic economy. Its destruction did not eliminate these innovations. It simply dispersed them to other ports and other cities. This pattern of destruction followed by renewal suggests something profound about the nature of human civilization. It suggests that we are an inherently adaptable species, capable not only of surviving catastrophic events, but of using those events as opportunities for growth and innovation. But it also suggests that we should be humble about our achievements. Each of the civilizations we have explored probably saw itself as the pinnacle of human development. The inhabitants of Mohenjo-Daro had created the first truly planned urban society. The citizens of Alexandria had gathered the knowledge of the known world. The residents of Akrotiri had built a trade network spanning the entire Mediterranean. And yet all were reduced to ashes and memories. This does not mean progress is futile or that we should live in fear of inevitable destruction. It means we should value what we have while we have it. It means we should take steps to preserve our knowledge and culture in ways that can survive catastrophic events. And it means we should maintain perspective on our place in the cosmos. From a practical perspective, this means several things. First, it means we should continue investing in monitoring systems that can give us early warning of potential catastrophic events. Our asteroid detection networks, our volcanic monitoring systems, our seismic sensors, all these represent crucial lines of defense against the kinds of events that destroyed past civilizations. Second, it means we should diversify our knowledge storage. The Library of Alexandria was destroyed because everything was in one place. The modern internet is more resilient because it is distributed, but it is still vulnerable to large-scale electromagnetic disruptions. We need backup systems that can survive even the most extreme events. Third, it means we should foster cultural and technological diversity. One of the reasons humanity has been able to recover from past catastrophic events is because different regions developed different approaches to the same problems. When one region was destroyed, others could continue and eventually reintroduce lost knowledge. But perhaps most importantly, it means we should maintain an attitude of curiosity and inquiry about these past events. Every site we have explored is telling us something about the capabilities and vulnerabilities of human civilization. Each new discovery is refining our understanding of what is possible and what we should be prepared to face. Advances in imaging technology are revealing details about these sites that were invisible to previous generations of researchers. Dating techniques are becoming more precise, allowing us to create more accurate chronologies of these events. Isotopic analyses are revealing information about the specific conditions that existed during these catastrophic events. Each of these techniques is providing pieces of the puzzle, but the full picture is still far from complete. There are fundamental questions that remain unanswered. What is the true frequency of these extreme events? Are there patterns in their occurrence that we could use to predict future events? What do they tell us about natural processes we still don't fully understand? And then there are the deeper, more philosophical questions. What does it mean for our understanding of human history that advanced civilizations have been repeatedly destroyed? Are we simply the latest iteration in a cycle that has repeated many times before? Or do we represent something genuinely new, a civilization that finally has the tools to break the cycle of destruction and renewal? I have no definitive answers to these questions, but I believe the very act of asking them is important. Because it is only by honestly confronting the evidence of past catastrophic events that we can begin to prepare for the challenges of the future. In the end, the sites we have explored are more than just archaeological ruins. They are reminders of the fragility and resilience of human civilization. They are testimonies to the power of forces beyond our control, but also to our capacity to survive and thrive despite those forces. They are, in their preserved destruction, time capsules connecting us to people who lived thousands of years ago, but who faced challenges fundamentally similar to our own. People who built cities and cultivated knowledge and created beauty, not knowing that everything would be erased in an instant. And yet, through that very destruction, their achievements have been preserved in ways they could never have imagined. The frescoes of Akrotiri are more vivid today than they would have been had the city continued to be inhabited for centuries. The Herculaneum scrolls contain philosophies that might have been lost forever had they not been carbonized by Vesuvius's pyroclastic flows. In this sense, these sites represent a paradoxical form of immortality. Through destruction, they have achieved a preservation that transcends the normal passage of time. They have been lifted from the ordinary flow of history and made into permanent monuments to specific moments in time. And perhaps that is the final lesson these sites have to teach us, that even in the most complete annihilation, something always survives. That destruction and preservation are not opposites, but different aspects of the same process. That the fire that consumes also purifies, crystallizes, and ultimately reveals. The peoples who were swept away by the flames were not truly destroyed. They were transformed, turned from living civilizations into eternal libraries, into history books written in fused stone and carbonized bone. Their voices still speak to us across millennia, telling us stories about impermanence and resilience, about destruction and renewal, about the end of worlds and the beginning of new ones. And as we continue unraveling their secrets, we become part of their story, linked through time by the common thread of human curiosity and the quest for understanding. In their destruction, we find not only warnings about our own vulnerability, but also inspiration about our capacity to persist, to rebuild, and to continue the eternal search for knowledge that defines what it means to be human. The flames that swept them away were devastating, but they were not endings. Because the true flames burning at the heart of human civilization, the flames of curiosity, creativity, and resilience, are inextinguishable. And as long as those flames continue to burn, human history will continue, cycle after cycle, building on the ashes of the past to create the worlds of the future.